This presentation, we are going to introduce our work, Optimal Transport of Diverse Unsupervised Text for Robust Learning from Noisy Few-Shot Data, published on ECCV 2024 with the authors Xiaofan Xue and Qiyu from Rochester Institute of Technology. Here goes the outline of this presentation. Learning to learn with noisy few-shot data is motivated by the unique challenges in few-shot learning, including the scarcity of labeled data and the presence of noisy labels. The following figure demonstrates our motivation. Figure A portrays the primary data distribution, which is contaminated by noisy labels. Figure D presents the unsupervised auxiliary text distribution. Their joint distribution is presented in Figure E. In Figure B, we observe the incompleteness and information loss after using data cleansing to remove noisy data. Although using augmentation in Figure C makes up for the information loss in a certain extent, it's limited by the diversity of existing data. The joint manifold in E indicates that directly merge the auxiliary data with the primary is ineffective and cannot fully recover the true data distribution. In this work, we propose to use optimal transport of the diverse unsupervised text. As observed in F, the learned shared representation only includes rich domain invariant information from the auxiliary manifold and recover the true underlying data distribution to the most extent. Based on this motivation, we propose the framework DUMPT. In the overall framework of DUMPT, the feature extractor extracts information from both primary and auxiliary tasks, and then use the absolute cleansing and diverse text selection to cleanse the data. The classifier and constructive head predicts the label of the primary and auxiliary examples, and the domain critic outputs the source of the examples. Essentially, the noisy label in the query set is removed by computing the loss of each example pair using the task-specific model. Based on memorization effect, higher loss indicates noisy data. Similarly, for support set, meta model is used for absolute cleansing. To learn from diverse unsupervised text, we first construct unsupervised only one-shot auxiliary text by first randomly sampling an images from the auxiliary dataset to form the support set, and then obtain the query set by augmenting the images multiple times using different augmentation techniques. The auxiliary loss is based on the summation of a series of auxiliary tasks. To select meaningful unsupervised text, we design a diversity criteria to filter out confusing text. The integration of diversity criterion is based on the assumption that the prediction vectors of two images from the same class are naturally encouraged to be close to each other. Therefore, we design the text diverseness based on the average of the cosine similarity between the prediction vectors. To enforce the learning of the domain invariant representation, we propose a critic model to discriminate the source of the input data, either primary or auxiliary. The learning of the critic is formulated as a min-max problem. Table 1 and 2 shows that our method outperforms the baseline across different few-shot benchmark data sets under non-transductive and transductive setting. We also study the impact of the task selection through threshold gamma. In conclusion, we propose a novel few-shot learning framework with auxiliary tasks that utilizes carefully selected unlabeled data under noisy settings. Our framework is theoretically and empirically proved to be effective and beneficial.